Imagine standing in a vast city, surrounded by countless buildings, yet hearing only silence. No footsteps echo, no voices carry through the streets, and not a single light flickers in the windows. The emptiness is overwhelming and you can't help but wonder, where is everyone? This haunting scenario mirrors a question that has puzzled scientists and dreamers alike for decades. This is the essence of the Fermi paradox. Despite the staggering number of stars and planets in our galaxy, we have yet to detect any sign of life beyond Earth. With so many opportunities for life to arise, why haven't we heard from anyone else? Why does the universe seem so quiet? The paradox is named after the brilliant physicist Enrico Fermi, who famously asked, "Where is everybody?" during a casual lunchtime conversation. His simple question sparked a profound scientific mystery that remains unsolved to this day. Consider this. The Milky Way alone contains hundreds of billions of stars, and astronomers now believe that most of these stars host planets. Many of these worlds orbit within the so-called habitable zone, where conditions might be just right for life as we know it to flourish. If even a tiny fraction of those planets developed intelligent life, the galaxy should be buzzing with activity, radio signals, spacecraft, or even evidence of vast alien civilizations. The odds seem to favor a universe teeming with life, not one shrouded in silence. Yet, despite decades of searching with powerful telescopes and sensitive instruments, we see and hear nothing, just an unsettling cosmic silence that stretches across the void. The paradox lies in this contradiction: the high probability that life should exist elsewhere, and the complete lack of evidence for it. It's a puzzle that challenges our understanding of both science and our place in the cosmos. Where are the radio signals, the alien megastructures, the unmistakable signs of advanced technology reaching out across the stars? Where are the traces of ancient empires, the cosmic footprints left behind by civilizations that may have risen and fallen long before us? The absence of evidence forces us to confront profound possibilities about our place in the universe. Are we truly alone, or is there something preventing us from making contact? Or is there a deeper, more mysterious reason for the silence, one that we have yet to comprehend? Some scientists argue that life itself is incredibly rare, a cosmic fluke that happened only once on Earth. Others suggest that simple life may be common, but intelligent civilizations are vanishingly scarce. Still others believe that civilizations inevitably self-destruct before they can reach out to the stars, falling victim to war, environmental collapse, or technological disaster. But new ideas suggest the silence might be due to barriers, physical, perceptual, or social, that keep us isolated. Perhaps there are great filters that most civilizations cannot pass, or maybe advanced beings choose to remain hidden. The answers may not be comforting, but they bring us closer to understanding our cosmic solitude. Each possibility forces us to reflect on our own future and the fate of intelligent life. The Fermi paradox isn't just a question, it's a challenge to everything we think we know about life in the universe. It invites us to look deeper, to question our assumptions, and to keep searching for answers. And it's a mystery that continues to drive our search for meaning among the stars, inspiring us to explore, to wonder, and to never stop asking, are we truly alone? To grasp the Fermi paradox, consider the sheer scale of the universe. The Milky Way alone has over 100 billion stars, possibly up to 400 billion. Most of these stars have planets, and tens of billions could be Earth-like. Our galaxy is just one of 2 trillion in the observable universe. The universe is 13.8 billion years old. Our solar system is a newcomer at 4.5 billion. Civilizations could have had a head start of millions, even billions of years. Imagine what a million-year-old civilization could achieve. The Drake equation suggests there should be thousands, even millions, of intelligent civilizations in our galaxy. With so many stars, planets, and so much time, the odds seem overwhelming. Yet, the silence persists. If the universe is so full of potential, where is everybody? The question only grows louder as we learn more about the cosmos. One sobering solution to the Fermi paradox comes from the very heart of physics itself, a reminder that the universe is not just vast but governed by unyielding laws that shape what is possible. The universe may be teeming with life, scattered across countless worlds, but each civilization is marooned on its own cosmic island, separated by distances so immense they might as well be infinite. These gulfs are not just empty space, they are barriers that no known technology can easily cross. In 2024, physicist Latham Boyle published a study revealing that even the most advanced forms of communication are fundamentally limited by the universe's own physical rules. No matter how clever we become, we can't outsmart the basic constraints of nature. The cosmic microwave background, a relic of the Big Bang, fills the universe with a faint but persistent static. It drowns out most signals unless they use extremely short wavelengths, making interstellar communication even more challenging. To send a focused message across even a few light-years, you'd need telescopes over 100 kilometers wide, structures so massive they would dwarf entire cities and push the limits of engineering. Building such colossal instruments is likely impossible, not just for us, but perhaps even for civilizations far more advanced than our own. The resources, energy, and coordination required would be staggering. If simply reaching our nearest stellar neighbor is this daunting, then communicating across the entire galaxy becomes an unimaginable feat, one that may never be achieved. The universe itself, with its relentless expansion and ever-present background noise, may be the ultimate barrier, not our lack of imagination or technology. We may be surrounded by life, with civilizations rising and falling across the cosmos, yet forever unable to reach out, touch, or even hear one another. The silence we encounter isn't a matter of choice or neglect, it's a fundamental law of nature, woven into the very fabric of reality. In the end, the cosmos may be fundamentally lonely, not by accident, but by design, a universe where isolation is the rule, not the exception. The physical barriers to interstellar communication are more than just inconvenient, they're insurmountable. City-sized telescopes, messages that take decades to arrive, and civilizations evolving between exchanges make real conversation impossible. Interstellar communication becomes a message in a bottle, lost in an ocean of time. The silence isn't about unwillingness, it's about the universe's rules. Even if thousands of civilizations exist, each is isolated, wondering if anyone else is out there. The cosmic prison hypothesis explains the silence without assuming life is rare or hiding. The universe may be full of life, but it's also fundamentally silent. We're all on our own islands, separated by an unbridgeable ocean. Our search for others may be like listening for a whisper in a hurricane. The ultimate great filter may simply be the physics of space itself. What if aliens are here, but we simply can't perceive them? This non-anthropocentric solution suggests the problem is our own limited perspective. We search for life like us, carbon-based, using radio waves, but the universe may host forms we can't even imagine. Philosopher Vojan Rakic argues we project our biology and technology onto the cosmos. Life could exist as pure consciousness, exotic matter, or in extra dimensions, utterly invisible to us. They could be right beside us, but we're blind to their existence. Our search for extraterrestrial intelligence may be doomed by our lack of imagination. The silence might be an illusion, a result of our perceptual blindness. The universe could be teeming with life, but we're deaf to its symphony. The cosmic city isn't quiet, we just can't hear the music. Imagine a worm in a garden, unaware of the human reading a book above it. The worm's senses are tuned to soil, not to the world of humans. In this analogy, we are the worm. Our senses and instruments are limited to our environment. What if advanced civilizations communicate in ways we can't detect, through gravity, extra dimensions, or unknown forces? We assume aliens would want to be noticed, but that's a human bias. Life could exist in forms as different from us as we are from rocks. We may be fundamentally alone in our perceptual universe, not the physical one. The search for alien life might be futile, not because it doesn't exist, but because we can't recognize it. Our isolation could be more profound than distance. It's a matter of perception. We may live in a bustling cosmic city, but we're trapped in a soundproof room. What if aliens know we're here, but choose to ignore us? The social rejection hypothesis, championed by Avi Loeb, suggests we're being deliberately snubbed. To advanced civilizations, humanity might seem too primitive or chaotic to engage with. They see our wars, divisions, and environmental destruction and decide we're not ready. Like the Prime Directive in Star Trek, they may avoid interfering with less developed species. The silence is a conscious policy, not an accident. This explanation makes the silence personal. It's about us. If we want to join the galactic community, we must mature as a species. The responsibility for contact is ours. We must become worth talking to. The silence reflects our own behavior and will only end when we change. Despite these theories, our search for answers continues. Scientists are expanding the search, from analyzing interstellar objects to building new observatories. The Galileo project, led by Avi Loeb, looks for techno-signatures, physical evidence of alien technology. The study of interstellar meteor IM-1 revealed unusual materials, deepening the mystery. New expeditions aim to find larger fragments, hoping for definitive answers. The Galileo Observatory monitors the sky for unexplained aerial phenomena, collecting vast amounts of data. More observatories are planned, creating a global network for rigorous, data-driven science. These efforts show our curiosity is undiminished, no matter how discouraging the theories. The only way to solve the Fermi paradox is to keep searching. The truth is out there, and we're determined to find it. So where does this leave us, on our small blue dot floating in the vast, silent sea of the cosmos? From this distant vantage point, Earth seems fragile, a tiny oasis of life surrounded by endless darkness. The latest solutions to the Fermi paradox are unsettling. Some suggest we're trapped in a cosmic prison, others that we're simply unable to perceive what's out there, or perhaps that we're being deliberately ignored by more advanced civilizations. Each of these possibilities forces us to rethink our place in the universe and to question what it truly means to be alone, or to be overlooked. If communication with other life is impossible, then perhaps our greatest responsibility is to cherish and protect the miracle of life we have here on Earth, nurturing it for future generations. If we're simply blind to the signals of the cosmos, then we must expand our ways of seeing and understanding, pushing the boundaries of science and technology to open new windows onto the universe. If we're being snubbed, maybe it's a sign that we still have growing up to do as a species, learning to cooperate, to solve our own problems, and to become worthy of joining a greater cosmic community. The quest to solve the Fermi paradox is, in many ways, a search for ourselves. It's a journey that challenges us to reflect on our values, our ambitions, and our place in the grand story of the universe. The silence of the cosmos holds up a mirror to humanity, asking us not just who we are but who we want to become, and what legacy we hope to leave behind. The quiet of the universe doesn't have to be a source of despair. Instead, it can be a powerful motivator, a call to action, to dream bigger, to reach further, and to hope more fiercely. This silence can inspire us to become better scientists, deeper thinkers, and more compassionate people, united by our curiosity and our longing to understand. Whether we're truly alone, simply blind, or just not yet ready for contact, our journey into the cosmos has only just begun, and the possibilities ahead are as limitless as the stars themselves. Our destiny may not be to find others, but to create a future worthy of the stars, a future where we become the kind of civilization that others might one day hope to find.